Thanks for that introduction. I'm Alex Fiannaca from Microsoft Research. So we're going to be talking a little bit about our work to improve expressivity and augmentative communication today, the work that I did with John Campbell and Paradiso and Meredith Ringel Morris. So a little bit of background, because this is a little bit of a diverse audience. So we work with people with ALS, although our work kind of applies to people with other motor neuron diseases as well. And generally what this means for the people we work with is that they, as the disease progresses, they lose control of all of the muscles in their body. In ALS, you generally retain control of your eyes. So this means that you lose your ability to speak, and all you have left is your eyes to control different technology to speak with the outside world, to communicate with the outside world. If you haven't heard of augmentative communication before, it's referring to this technology to let people communicate in different ways. The pictures here of Steve Gleason in the middle and Stephen Hawking on the left, also Lou Gehrig on the right. But in front of Steve Gleason and Stephen Hawking, you see computers that are mounted on their wheelchairs, and those are augmentative communication devices. So the way they work is they have a camera that's mounted at the bottom of the PC that emits infrared light that creates the red eye effect, and then there's a camera that tracks the red eye effect and watches for their pupils to move, and we calibrate the system and map the movements of their pupils onto a position on the computer. And then using kind of the position they're looking at on the computer, we can do things like if they stare at a particular target for long enough, we can inject a click. We call it dwell clicking, and that allows them to control the computer. So typical augmentative communication systems, like a very common one would be the Tobii Dynafox that you see here at the bottom. Given this kind of slow, challenging interface to work with a computer, it's not surprising that these systems have a lot of problems. The one that we're particularly interested in this work today is that the speech output from these systems is generally apathetic. So what I mean by that is that when you type something into one of these communication systems and you press the play button and it generates text-to-speech, the speech you get out is just default text-to-speech. And that sounds like it's being, someone's just reading a book, kind of like a flat voice. That's unsurprising because text-to-speech systems are trained on lots and lots of audio of people reading books, right? But the problem is if you're using this as your sole mode of communication, you have a very hard time being expressive in that communication. So if you're angry and you're trying to shout something, it's going to come out flat. And that's a major problem. In work that Sean Kane did last year, he showed that there's a lot of barriers that people with ALS face because of this, and they have to come up with workarounds. So workarounds like if you're trying to say that you're angry and you would have shouted it before, now you will instead say something like, I'm really, really, really angry. And each of those reallys is going to take you a long time to input because with text-to-speech or with eye gaze systems like this, you only are able to input around 10 words per minute. So this could mean that in order to be angry, you have to type for 3 minutes or 4 minutes just to say something simple. And so that's a major problem. So this raises the question, if these systems are producing flat output, is it even possible to produce expressive output? And the answer is that yes, some text-to-speech engines have expressive capabilities built into them now. They're not amazing, but there is more expressivity that's possible. So both IBM Watson, Nuance Liquendo, and Sarah Voice from Sarah Proc are examples of text-to-speech engines that can do this. So in this work, we're introducing the idea of voice setting. Voice setting is the process of authoring or editing speech properties of text, and this is analogous to typesetting for visual display of text. So the idea is we want to give people with ALS the ability to craft the way their speech sounds when they're typing it into a system. So how does this look? Essentially, we have input text that you type into your augmentative communication system, and you'd add some form of expressive markup to it. That would be combined by the system to generate an expressive markup version of the text that can be passed into a text-to-speech engine, which will generate some output for you. So let's take a look at an example. If I wanted to say, I'm really angry at you, I'd add some sort of markup. In this case, we'll just use an emoji to indicate kind of how I want to say this. I'm angry. That will in turn generate some expressive markup here, which is very different from the base markup you would see for text-to-speech. So we have things like a spurt, which is, in this case, it's the ARG spurt. This is specific to the Sarah Voice engine. But the idea is it's a vocal sound effect, not text. So this is actually like the kind of sound. But you can think of this as laughter or like or whatever it may be. And then there's also this voice tag that specifies an emotion for text. So the I am really angry at you text is wrapped in the emotion cross. Sarah Voice is a Scottish company, I believe. So instead of angry, they use cross. And then if we were to render this, you'd hear something like this.
I am really angry at you.
Okay, so it doesn't sound amazing, but let's compare it to what it would have been if we just used the standard output.
I'm really angry at you.
So I'll play that one more time just so you can compare. So here's the standard output.
I'm really angry at you.
And here's the improved version.
I am really angry at you.
So it's a definite improvement. So there's kind of two sides to this problem. I'll say that what we're interested in today is the first part, the how do you actually specify the input to the system to tell it how you want to say the text. There's also the question of how do we make text-to-speech engines just be more expressive? Because as you just heard, that sounded more angry, but that wasn't like the gold star of I'm super angry right now, right? We'd like to make it have a larger range. There's a lot to be done there, but what we're going to focus on today is kind of the authoring end of things. So in order to do this, we worked with a bunch of people with ALS and kind of iteratively designed several interfaces. And I'm going to go through kind of two different ones on different ends of the editing spectrum here. So the first one is the Expressive Keyboard. This is our kind of research platform augmentative communication system. Essentially, it's an on-screen keyboard. You type in text to the keyboard, you hit the play button up at the top there, and it renders text-to-speech for you. What we did with the Expressive Keyboard is we added in this row of emoji, and each of the emoji maps to a particular operation over the sentence that it's bound within. So the angry emoji that you saw before in the previous example, if you put it into the sentence here, it's going to change the tone of the voice, and it's going to insert that vocal sound effect. Any of these emojis have the ability to do a combination of those two things, changing the tone of voice and inserting vocal sound effects. We also use punctuation slightly differently here in that we allow users to customize the white space that punctuation will inject into a particular sentence. So if you want a dramatic pause, you can now have that, and you can't as in standard text-to-speech right now, or standard AAC systems. And then also there's a problem where a lot of times sentences that are questions are ambiguously worded such that if you put a period at the end, it would sound like a statement, or a question mark at the end, it sounds like a question. And with those sorts of sentences with text-to-speech, they generally come out sounding like a statement. And so if you add multiple question marks at the end of a sentence, we actually lift the pitch to indicate that it's a question. An example of that would be Susan is here today versus Susan is here today, right? Okay. So this is a very crude but simple approach to adding markup for how you want to say something. It means you only have to input maybe one or two characters, and from that you can change the way something sounds to try to better convey what it is you're saying. So it's very powerful in that it's so simple. What we noticed when working with our users was that people also really valued the vocal sound effects on their own. Sometimes they just want to use the vocal sound effect as a response to something someone else was saying. So we created what we call the active listening mode. There's this little icon up in the upper right-hand corner here that's a ear. If you click on that, it opens up a menu that gives you direct access to the various vocal sound effects in our system. And so this allows you, if someone else is talking, to quickly respond to them with laughter or with an angry kind of grunt, which right now, if you're trying to interject with someone using a standard AAC system, it would take you maybe a minute to write a response, even if it's really simple, which means that you've missed the opportunity to respond. So this gives you a quick way to respond with generally recognized kind of voice gestures. So that's on the very simple end of things, but there's times in which you want to really control what the output sounds like. So for that, we created the Voicesetting Editor. So if you were to type something out in our keyboard here, you could hit the little edit icon, and that would open up this editor view. It's a little hard to see with the lights in here, but each of the words is its own hit target, and in between it there's kind of light gray circles that are invisible in here. You'll just have to take my word for it. that represent spaces. And each of these you can interact with. So as an example of that, what I'll do first here is I'll select the first word only, and then I'm going to select the exclamation point at the end of this, and a menu will open up that lets me change expressive properties over all of the text I just selected. So in this case, I want to make it angry. So I'm going to look at the emoji icon, and then I'm going to choose the angry emotion here. And we have an overline that appears over all of that text, and a little icon at the upper left-hand side of that specifies what that overline is. So it's an angry emotion across everything. We can also select individual words. So if you looked at only, a menu would pop up immediately around only, and you can change properties about that particular word. In this case, I'll insert an effect. So I'll look at the effect button, and I'll choose arg again. And now arg gets injected into the editor, and it's a new token you can directly interact with. We can also do other things, like we can change the volume of particular portions of the speech, or we could slow down particular portions of the speech. We can add emphasis to individual words. If we did, for instance, if we were to add emphasis to Jeff, it would change the boldness of the font to indicate what the emphasis is intended to be. And we could do things also like we can change the amount of white space. And if we were to do that, it would stretch or shrink the space between words. So there's a visual analogy for all of the different speech properties that we directly map into the editor here. And then along the way, you have the ability to play the original text without any changes and the changes you made so far, and undo and redo kind of standard editor experiences. So this is a much more complicated experience. There's a lot more you can do here. So I think of this as kind of a comparison of Markdown versus Microsoft Word. In Markdown, you put in one character and you get some general effect that you don't have much control over. In Word, you can control every last little thing. But the benefit of Markdown is it's really simple, right? So in our Expressive Keyboard, you get really fast changes, but they're probably not exactly what you wanted. Here you can get exactly what you want, but it's going to take a little more work. So we did some evaluations of this. I'm simply for time going to kind of shoot through some of this because there's a lot of our evaluation in the paper that we just aren't going to get to today. So the first thing we did was we wanted to make sure that before we put this in front of people with ALS for a final evaluation, that the output they're going to hear actually represents something closer to what emotion they might have wanted to hear. So we did a quick speech quality analysis with listeners who are able-bodied listening to kind of gold standard output, the best we could possibly make with the system. And in general, we found that people were able to better or understand the emotion and expression that we were intending to have in the speech over the default text-to-speech system. But there's a huge amount of room to improve just on what text-to-speech can do here. So we shouldn't shortchange that. Then we did a series of studies with people with ALS and had them use the system in a series of ways. All I'm going to do today is kind of jump on the major points that came out of this, the major feedback points. So the first was we were kind of surprised by this with how much feedback we got here, but people really valued the power of vocal sound effects. So simply being able to quickly laugh or to grunt or to scoff, which is something that's not easily accessible in AAC systems today, was really powerful. So an example, participant PL7 said there's not a lot of difference between the different voices. The sounds, talking about the sound effects, have more impact in the different voices. So people valued that. We also heard a lot about kind of users' empowerment and the ability for them to customize their personality that you perceive through the text-to-speech system. So participant 1 said, this is very valuable work. There are few voice options today, so this would be a way for me for the first time in 5 years to hear my own voice again. And participant P2 said, it feels like you can add a bit more personality to it, referring to adding personality to his voice in the text-to-speech system. We heard a lot about the time-effort trade-offs, and we discussed this a lot with users. And in reference to kind of when you would use the more complicated editor scenario, we heard a lot about kind of crafting of important things. So this might be when you're going to the doctor tomorrow and you're really upset about something and you need to tell him something, you want to craft it ahead of time so it's ready to go when you get there. Or for PL1, participant PL1, he said this would be great for speeches. And he's referring to the fact that he gives speeches, he still gives public speeches, and he spends a lot of time working on the speech. I mean, he will stay up for almost 24 hours straight writing a speech because it takes that long to write a speech with eye gaze. And having this would allow him to really customize kind of how that speech is conveyed. And then also the spouse of PL7, so this would be great for crafting a special communication, kind of talking about a spousal communication, right? Whether that be love or even when you're angry, a lot of people talk about the fact that they want to be able to yell, but they can't yell anymore, right? You want to be able to fight, but you lose the ability to fight through an augmentative communication system. And then we heard a lot about the room for improvement in the actual text-to-speech system itself. So participant PL, or the spouse of PL6 said, intimate and frequent conversation partners like myself would learn to recognize the differences between tones, but I suspect a more occasional conversation partner might not be able to discern them. So if you were to take this text-to-speech engine we used, which is the Sarah voice engine, and listen to kind of the variations of the 4 different voices that it can use versus the default, you would notice that there is a difference between them, but it's not always clear exactly what that difference is. It's not, the distance between the voices is not necessarily great enough. A lot of work is being done in the text-to-speech field to improve this now, but it hasn't really made it into systems that we can use yet. And we also recognize that there is a huge amount of opportunity for future work here. So the first being that when people with ALS are first diagnosed with ALS, it's generally before they've lost the ability to speak. They may have some dysarthria, meaning that their voice is affected, but it's not yet gone. And so most people will voice bank, meaning that they will read a ton of phrases, they will bank all of those, and then later have them so they could play them back again. And so this would be a great thing that we could integrate into the active listening mode. So instead of having generic laughter or a generic scoff, you actually have your own laughter, your own scoff. So you're keeping your own personality and voice there. We could also have expansion to multiple languages and personas. So you can think of this like when you're reading to your child, like Steve Gleason. He has a young 3-year-old child, and when he's reading to him, he would love to be able to read in different personas for different characters, right? I'm sure all of our parents have done this when we were kids. And we would love to be able to bring that into the system here, as well as customizable pronunciations. And then also, we think we could extend this, bringing in AI kind of for adapting the emoji operators in the Expressive Keyboard. And this could either be based off of using your voice banked audio to automatically customize those operators to the way you speak or you spoke before. And we could also use it to automatically update and adapt those emoji operators to the way you use the system. So that over time, it gets closer and closer to what you would have done in the editor if you went to use the editor, but instead it just happens natively in the emoji, the Expressive Keyboard. So with that, I'm going to conclude and welcome any questions.
Okay, thank you. We have time for 1 or 2 questions.
That's really nice work. I like it a lot. I'm Ray Zhang from University of Washington. I would like to ask one question. So now, like the system have several emojis, right? Like laugh or angry. But in the future, there might be more complicated, like too many expressions, and there might be too complicated to select them, right? So did you like think about that area?
So we spent a lot of time choosing the emoji that we wanted to use. We actually ran a preliminary study that's not in the paper, where we tried to isolate down the emoji that best represented the most general emotions that covered the largest space of emotions, right? So a lot of work went into this. We actually don't imagine that we would extend the set of emoji very far, because the entire point of this Expressive Keyboard is to be incredibly simple and quick. So we wouldn't want to expand it, have a ton more options, and now make it really hard to figure out which one to choose in any given moment. They're intended to be generalizations.
Okay, and a little suggestion, I guess, like if you make every time laugh the same tone, it might be boring or like perceived as like same. So maybe you can make some randomization or like add some noise to the tone, like to make every time the tone is different a little.
Yeah, I think that that's certainly, there's certainly some ability to do that if you are to build the text-to-speech engine yourself. Of course, we weren't building it ourselves here, right? We were using an available one. But I also think that the degree of kind of that random nature in there doesn't matter quite as much as just the general ability to have some variance, right? We're going from 0 change in your voice to a lot of change, right? Having now like variation between every single time you say something in an angry voice is not necessarily going to make a huge impact. So, yeah.
Okay, I'm going to ask, while Jeremy is setting up, I'm going to ask another question. So one of the things I really like is that you can tailor, like really customize throughout the sentence and really determine that. I was just wondering if you thought about, maybe this future work, sort of transfer from the expressions from one sentence to another, or maybe even pair it up with sentiment analysis that you could get a sense of that. There's this startup called Lyrebird where you can like record, you might have seen that, right?
Yeah, so this is another thing we spent a lot of time on. We thought a lot about, can we do a lot of this automatically, right? Sometimes just the text you write is enough to be explicit about how it should be said, right? Like if I use an explicit word and I'm directing it at you, I'm probably yelling, right? So we thought a lot about that. We just didn't get around to it. There was a lot going on here. So
Cool.